Hi folks, my name is Manish Gupta, and in this video I will talk about this model called as VideoCLIP. It is trained using contrastive pre-training, and it is really nice for zero-shot video text understanding, several of those video text understanding tasks. Right. So let's start by talking about what kind of video understanding tasks VideoCLIP can do and is good for. Right. So I'll talk about 4 tasks here. The first one is text to video retrieval. The idea is given a text and a collection of videos, can I have a model that can find me relevant videos for this text? It's basically text-based video search, right? Uh, Multiple choice video question answering. So here, given a video, a question, and multiple candidate answers, how can I have a model that can choose the best answer out of those multiple choice options, right? The third task is action segmentation. So essentially, when I have a video and if I look at every frame of the video, can I assign every frame of the video with one of the predefined labels to separate out meaningful segments of videos, right? So this is very similar to part of speech tagging or named entity recognition task in NLP, where for every word, you basically want to figure out a particular label from a set of predefined labels. Right? The fourth task is the action step localization. Here, for every video, it's basically associated with a particular task which has S different steps. So think of recipe videos associated with, let's say, 10 different tasks, right? 10 different steps. So there's a task, and then you have multiple steps associated with it, where each timestamp, each frame is sort of, or rather, where each task, or rather, sorry, each step in these S steps is described using a short text. Okay, so you have each video belonging to some task, and in the collection there could be like 100 tasks. For each task, there are a bunch of steps, and each step is sort of described using short text. So now the task is to basically take every video and take every frame in the video and assign it to one or multiple steps in the associated task. So first you have to figure out which task the video belongs to. And then within that task, there could be several steps. You have to figure out which step this particular frame belongs to. Yeah. So it's very similar to action segmentation, except that the label set is not really predefined. In action segmentation, you have a predefined set of labels, let's say 50 labels, right? And you have to basically assign every frame in the entire collection to one of those 50 labels. But in action step localization, this label set is actually defined at a granularity rather than the entire collection granularity. Also, in action segmentation, there's a special label called as outside label. Basically saying, none of the useful labels are applicable to this frame, then you can call it outside. But in action step localization, there is no outside label as such. Okay, so given these interesting video tasks, how do you basically solve them? So VideoCLIP architecture is the one that can be used to solve them. And now, of course, as you can understand, you're going to first take the text, which is a part of each of those tasks, text to video retrieval or question answering. You have text there as well, and so on. So you basically take the text part and you encode it using BirdBase. So BirdBase uncased. In fact, you encode it using all the 12 layers of the BirdBase uncased. You take the video, you basically make the video first pass through a CNN S3D, and then you project it by a single dense layer. And then you take the output and encode it using 6 layers of the BirdBase uncased, the first 6 layers of the BirdBase uncased model. Right? So that's how you encode the video and the text. So the video basically is encoded into a fixed size of 32 video tokens, and the text basically contains 61 text tokens. So they kept the text tokens almost the double as video tokens because typically they observed that their sampling rate for video was according to that. So they sampled about 1 frame per second. So it basically sort of seems to be like people can speak like 2 words while they have like 1 frame per second. So that's how the ratio is. Okay. Now, so you pass them through a transformer, essentially BirdBase uncased models, and then at the end of it, you take average over 32 tokens and average over 61 tokens so as to get the one embedding for the video part and one embedding for the text part. One single representation, average pool representation. Okay. And for pre-training, they basically use how to 100 million dataset, which contains a whole bunch of video text pairs. Okay. Now, the idea is that so the architecture is pretty simple from that perspective. It's basically just transformer models, 2 different transformer models initialized using BirdBase uncased. Yeah. Of course, on the video side, you also have a pre-trained CNN, a frozen pre-trained CNN, which is used. Yeah. So that's that. Now, how is this trained is the most important part. So the model is pre-trained using contrastive approach. So a contrastive approach basically means given a text and negative videos, you want to ensure that the positive text video pair turns up at the top or is ranked at the top compared to all the negative text, all the negative text and video pairs, or positive text and negative video pairs, right? So essentially, you want to make sure that the positive guy ranks at the top compared to all the negative video comma text pairs. Okay. So, well, so that is what they use. They use contrastive loss and they use symmetric contrastive loss, basically meaning you want to ensure that you care for positive video and negative text pairs and positive text and negative video text pairs, video pairs. Okay, so basically they use the softmax with a particular temperature, and you want to ensure that the positive video text guy is ranked higher up compared to the negative video text guys in that senses. Okay. Okay. So that's that. So that's typical simple contrastive pre-training. However, they basically have novelty in terms of how they sample the positive pairs and the negative pairs. So I'll talk in more detail about how they sample the positive pairs and how they sample the negative pairs on the next slide. Okay. But they actually do sampling, a different sampling for every epoch. So that is what is shown here in the picture, right? So essentially you have, let's say if you essentially have a positive video text pair, which is being shown here. So there is some piece of text and some clip that is there from this video. There's some piece of text and there's some clip from this video. That gives you some positive video text pairs, and you notice that they take overlapping video text pairs in the sense that there is some transcript associated with the part of the video, part of the clip, the clip of the video, right? You don't take exactly that, but you take a slightly overlapping one. Okay. And then for the negative ones, for the negative pairs that you need for the contrastive loss, what they do is to basically take other similar videos. They don't take negative pairs from the same video. They take other similar videos, and then they essentially consider them as the negative pairs. That's how they form batches for this epoch. And then for the next epoch, what happens is that this similarity of videos changes. So remember, negative pairs have to be sampled from other similar videos. Now, as you're training, your encoder is also getting trained, so your similarity changes, and therefore you retrieve different set of videos, and therefore you train on different positive and negative pairs. So in more detail, this is how the positive pairs are sampled, and this is how the negative video text pairs are sampled. For positive text video text pairs, this is what they do. They sample a text clip. Text clip is basically just some subtitles, right? From some random associated to some random video in the entire collection. Okay. Then they sample a timestamp within the boundary of the text clip as a center for a video clip. Now, in the pre-trained data, you have these text and video clips aligned already. So therefore, when you sample a text clip, you basically take the video and you take the center. So you associated video clip and you take the center of that. And then you grow a video clip with random duration up to 32 seconds from the center timestamp. So first, your video clip is not going to be of exact same size. It can be of different sizes. So basically saying you sample a random duration of 32 up to 32 seconds. And then from the center timestamp. So, you start from the center timestamp and essentially have a random duration. You basically grow the clip around that. Okay. So now, essentially, it says that you don't take the exact matching clip with the text, but the overlapping one. And the reason why they do that can be understood by a simple analogy. Let's say there is a video clip, right? And in the video, the guy is saying that, hey, I will help you, or rather, I will show in this video how do you cook paneer butter masala, right? So now when the guy is saying this exact sentence, I'll show in this video how to cook paneer butter masala. There's no paneer butter masala appearing in the visual part of the video at all, right? So it appears later down the line. So by doing this overlapping kind of business, what they're trying to do is to bring in at least some semantic visual aspect of the video and link it to the text, which basically makes good semantic alignment. Okay. There's a pretty interesting insight in this paper. Basically saying don't align your audio or text directly exactly with the visual aspect in the video, but align it slightly, in an overlapping manner. Slightly overlapping manner, because typically the visual aspects come later compared to what was said in the video. Okay. Now, for negative pair mining, this is what they do. They do what's called as retrieval augmented training. So for every epoch, what do you do? So you have to, of course, do retrieval augmented training. So the idea is going to be like you have a positive video or other positive video text pair. you're going to take this positive video and you're going to find several other videos which are similar to this guy. And you're going to mine the negative clips from there. So you're going to mine negative video text pairs from there. Okay. So to be able to do this similarity search, essentially you need k-nearest neighbor support, and which is why you essentially index everything. So for every epoch, what are you going to do? You're going to first get a representation to be so that you can index it. So a dense representation for every sample. So you take the video and text embedding for that sample, and you take the average. You index all the videos using face index. And then you basically want to sample, entire training data set for an epoch. So you want to sample B batches, B meaning entire set of batches on which you're going to do pre-training for this epoch. So for each batch, what do? Well, you sample a video, basically because you have to get a video text pair. So basically you sample a video. You then sample K videos from the 2K nearest points. So basically, when you sample a video, you basically have its 768 size representation. You go to the face index, get 2K nearest videos or nearest samples. And from that, you basically randomly choose K of them. Okay. And once you've created this training data, pre-training data, you basically train for an epoch using these B batches. That's how you train for every epoch. Right? So this is nice because it allows you to have very interesting hard negatives, right? Rather than negatives just mined from the same video. Sometimes what happens is negatives mined from the same video could actually be positives, because the guy just said, how do you cook paneer? I'll show in this video how do you cook paneer butter masala. And well, you thought that this was, that any other random clip in the video could be negative. But well, I mean, random clip from the video highly likely will contain paneer butter masala. So it's not literally negative, right? So therefore, they basically believe that this kind of way of doing retrieval-based augmented negative pair mining is going to mine hard negative pairs without any noise. So how does VideoCLIP perform? So the slide is busy, but I'm going to show you here how does VideoCLIP perform on all of those 4 tasks that we started this video with. Okay, so text to video retrieval. So input is the text and you want to find relevant videos from a large collection. So they show experiments on 2 data sets, UCook dataset and MSR VTT dataset. They experiment with supervised baselines and zero-shot baselines. So it's a zero-shot method. So the idea is that zero-shot basically means you don't fine-tune for this particular task. You just use the zero-shot method, a zero-shot model, a pre-trained model, right? Supervised means you fine-tune on this particular task, data set for this particular task. So what you observe is that and they compare on these recall-based methods, the retrieval tasks. Of course, you basically need recall metrics, recall at 1, recall at 5, recall at 10. And what they observe is that, if you compare with supervised baselines and you actually even look at zero-shot video clip, it's actually comparable. So if you compare zero-shot video clip with supervised baselines, you actually get sometimes better results. Okay. Of course, if you basically compare with the fine-tuned clip, it basically establishes state of the art. So no method is as good as the fine-tuned video clip, right? Now, if you look at MSR VTT dataset, the story is similar. Even on MSR VTT dataset, fine-tuned video clip is actually pretty comparable. So of course, there are some methods which are slightly better at larger recall values, but if you look at recall at 1, fine-tuned video clip is the best. Now, the same trend holds across other tasks also. So video question answering task, you see that the zero-shot model is 73.9, but then the fine-tuned video clip model is way better compared to any of those several existing methods, right? On action segmentation, again, you observe that the fine-tuned video clip gives you better results, but the pre-trained version is not that bad. Similarly, on the action step localization task, you of course observe that again the fine-tuned clip establishes state of the art. Okay. So in summary, in this video, I talked about VideoCLIP, which is an approach to pre-train a video text model for zero-shot transfer to downstream tasks. Right. The way it is trained is using contrastive training, which contrasts the temporally overlapping positives, not exactly overlapping positives, with hard negatives coming from nearest neighbor retrieval. Okay. Also, we observed that VideoCLIP established state of the art for sequence level text video retrieval, video question answering, token level action localization, and also action segmentation. Okay. You can play around with the code and the models here. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage.